Hey guys, welcome back to the third and final video about the energy topic for physics GCSE. Today we're going to be looking at just some different energy sources and kind of how they impact the world around us. So let's get started. So first of all, let's talk about energy resources and their uses. So you've got non-renewable energies, and I'm sure you're all very aware of what all of these mean, but I'll go over it anyway. You've got non-renewables, so that means that they will run out. They generally cause harmful emissions or waste, and we're trying to move away from them, but they are very reliable and very inexpensive as well. But you've also got renewables. They will never run out. So we're trying to move to them because our fossil fuels and other non-renewables are looking like they will run out very shortly. So we want to move to renewables. The only problem is that they are more expensive, or they might not be so efficient and kind of reliable. Definitely not as much as fossil fuels are, which is a shame. But we need energy because transport uses loads of energy. Cars, you've got petrol and diesel cars. You've also got your electric cars. Where do you get the electricity from for the electric cars? You use fossil fuels to burn them on an industrial scale, or you use renewable energy. You need lots of energy for transport. Trains, buses, planes, they all need some source of energy. And you also need it for other things. Heating, you need boilers and things like that for your central heating. Where do you get the energy from? You burn stuff. You burn gas, you burn oil. Where do you get electricity from? Power stations, they burn coal, they burn oil, they turn turbines and they send the electricity out through the national grid. You know, we need energy for a lot of things, so it's important that we get our energy sources fixed and completely safe, but also reliable as well, because without them, our whole world as we know it would crash. So let's talk about a bit about renewable energy. So you've got various renewable sources. You've got wind power. So these utilize wind turbines. The wind turbines kind of face the wind. The wind passes by the turbine. It causes it to spin. This turns a motor, and the motor generates the electricity. Solar cells are a little bit different than the other sources that I'm going to be talking about because they use you can get solar power where it does heat water and it turns a convection current, which turns a motor, which generates electricity. But you can also get photovoltaic cells, which turn sunlight directly into electricity. So they're a little bit different, but they all kind of work along the same principle generally. You've got geothermal, which is where you dig down deep into the ground in volcanic active areas. You put water pipes down there, that makes a convection current, and you can either use it for heating, or you can put a motor in the convection current and it turns the motor and generates electricity. Now, Iceland is particularly prominent for this. Most of its power does come from geothermal energy, which makes sense because it is one of the most volcanically active sites in the world. You've also got hydroelectric power, which involves building a massive dam and letting water run through it at a controlled rate. Each of the kind of jets of water that you might see coming out of the other side of the reservoir, each of those jets turns a turbine, which turns a motor, which generates electricity. So a good example of this is the Three Gorges Dam in China, which is the largest hydroelectric dam in the world. It's quite an architectural feat, so that is the biggest hydroelectric dam in the world, which is quite amazing, really. You've also got wave power, which is where you have tiny generators on the coast, and the waves make the turbines move up and down, and these turn turbines, which turn the motors, which generates electricity. And you've also got tidal energy as well, which is is kind of a mix between wave energy and hydroelectric power. You build something similar to a dam, but it allows water to pass through both ways, and it doesn't create a reservoir on one side. And as the tide rises and falls, so these will most likely be on tidal estuaries, kind of like your ports in Wales and Cornwall and places like that. So you build, it's kind of like a wall that lets water flow through both ways. And as the tide comes in and as the tide comes out, the water moves through at a controlled rate, turns the turbines, turns the motors, and generates electricity. Now, each of these has their own positives and their own drawbacks. None of these themselves directly emit any greenhouse gases or harmful waste, which is great for the environment, much better than fossil fuels and nuclear power. However, they are generally not as reliable. Solar power really requires a sunny day to work at a decent and reliable efficiency. Wind power, you need wind, so if you've not got a windy day, then they're just sitting there doing nothing. Geothermal, generally no problems with that. I mean, it can be a bit destructive, drilling all those pipes into the ground. Dams are brilliant, but they destroy tons of habitats, and people have to evacuate their homes for the reservoir to form. It's quite a destructive process. And wave and tidal power stations, they are kind of put right where you'd expect large colonies of birds, or flocks of birds, I should say, or large amounts of wildlife to live, so it could be quite disruptive to them as well. And obviously, if you're on the beach surfing, say, you don't want to crash into a wave power generator, do you? So they each have their positives, but they all have disadvantages as well, which you'll notice is another recurring theme in this energy sources topic. So now that we've talked about renewables, let's talk about biofuel, which is actually another renewable, and the non-renewables. So biofuel is kind of a bit of a weird one because it is a renewable, but it is more similar to fossil fuels than it is to renewables. So your biofuel is when you get your unwanted biomass. So it would be stuff like feces, or kind of the husks of crops, or things like that, that there are no uses for, but are side products of farming, or, well, animal or plant farming, really. And what you do with these is you get a biomass boiler, and you put them in, and it burns these bits of organic matter, and these release energy, because everything has sugar in it. Plants store glucose in the process of photosynthesis. Animals release the glucose in respiration, but there's always a bit left stored as excess energy, and there's some stored in fats and things like that. So it makes use of the wasted energy in plants. However, burning these does release things like carbon dioxide into the atmosphere. So, which is why it's a bit of a weird one, because it is renewable. You know, the cows aren't just going to stop making feces. You know, we're not going to suddenly stop growing corn or start eating the husks. No one's going to start doing that. So they'll always be there, but it can cause environmental problems, which is generally not the same in other renewable energies. But fossil fuels are non-renewable. They are completely going to run out. They're not going to be there forever because they take so long to form. Your kind of examples of your fossil fuels are coal, oil, and gas. So just think, when you're burning fossil fuels, it makes the cogs turn: coal, oil, gas, cog. Quite pleased with that one myself, to be honest. But the main advantage for these is that they're very reliable, and they will always work. You get a shipment of coal, you just put it in the boiler, you kind of set fire to the coal, generates heat, causes the water to start to form a convection current in a separate system but close to the fire, turns a motor, generates electricity. It's the same for the other ones as well, although oil and gas are generally used in heating a lot as well, which is similar but not exactly the same. But these, we're trying to move away from fossil fuels as much as we can, because the extraction of them can be harmful. So coal, they have to lay open massive stretches of ground, dig mines. The miners themselves can be harmed in the mines. There can be collapses or explosive gases, but you can also get kind of just massive environmental damage as well from the kind of especially open pits where you just dig everything up from the surface down until you find some coal. But there are also processes like hydraulic fracturing, or otherwise known as fracking, and like your nodding donkeys and things like that. They are also harmful because you've got to dig deep down. They can cause earthquakes, water pollution, other things like that. So the extraction of these substances can be harmful. And these substances also cause climate change and other harmful side effects. So coal contains sulfur impurities, which means that when it's burnt, it releases sulfur dioxide, which causes acid rain, which we don't want because we don't. It would damage plants, but it would also damage us and the other wildlife as well. Um, so on a slightly different note, there is another non-renewable that exists called nuclear fission. Now, this is different to fossil fuels because you put in your uranium rods. This comes up in another topic, so I will do this more in detail. You put in your uranium rods into the reactor. It turns various convection currents because of the heat emitted by the radioactive decay, and it generates electricity that way. But your it doesn't release any greenhouse gases, any emissions at all, really. So that's great. The problem is, though, it's very expensive because safety is a massive issue because of the radiation. But also, it produces radioactive waste, and you've got to store it in massive underground caverns, and it's just an absolute nightmare to get rid of because it's not safe to just kind of put in the bin or kind of just leave out. You can't do that because it's not safe for anyone at all. So it creates a lot of problems, and it's a very controversial energy source because a lot of people don't want to be exposed to this radiation, even though if you live a decent way away, it's a very low risk. So to finish off, let's talk about trends in energy use. So as the global population increases, we're going to need more energy. As technology becomes more widespread, we're going to need more energy. So where do we get this energy from? So at the minute, we still depend heavily on fossil fuels. They are the predominant energy source that we use. Because they're so reliable and cheap, and it's not economic to move away from them at the minute. But we are increasing the proportion of renewable energy that is being used. So you've got lots of wind farms popping up, solar power farms, things like that popping up all over the place, which is great because it is helping to stop the issue of climate change. The problem with that, though, is that renewables are still limited and they're very expensive and they're not very reliable. So it's not economic to move to them entirely just yet. But technology is being improved. You're getting new cars, new other forms of transport. So, we've got electric or hybrid cars, and that goes over into other forms of transport. You've got new methods of heating, like using not photovoltaic cells, but the other form of solar energy to heat. And you've got other forms of heaters as well, like biomass boilers and things like that. So new technology is being developed, and it is getting there. We are getting there. So with that being said, I hope this was very informative. So I'll be publishing these very soon, and I hope that you have learnt a lot. So goodbye and God bless.